All right, welcome back to the video lectures for this module. We're going to continue our discussion of inductive reasoning, more specifically of enumerative induction, by turning our attention to sample size. That's where I want to begin for this lecture. So one point that I want to call your attention to is the fact that this is a place where hasty generalization can certainly come into consideration. Remember, hasty generalization was a kind of informal fallacy where the problem is that we are moving from some instances of knowledge to a more general, more universal claim, if you will, about things that we don't know about. And sometimes that can be problematic. Maybe we should not be moving from, some small select piece of information to a more broad general claim if we don't have enough information, enough evidence to make that move, to make the transition from, an instance to the general categorization of some particular group. Right. So there are cases or examples on page 93, 94 that I want to draw your attention to as it relates to the sample size not being large enough in order to make the move to what we don't yet know. So I'm going to read from the textbook because I think it does a nice job of actually making this point. He gives an example that involves the kind of research that actually happens quite a bit. This is research that goes on university campuses. So you may have come across this kind of research before. So the example that's given at the bottom of 93 in the Vaughan text, it's sort of a toy example, but I think you'll get the picture of what's going on here. So Vaughan says, let's say that you decide to conduct a survey of college students to determine their attitude towards federal deficits. So you stand around the student center and query the first 5 students that pass by. 4 out of 5 say that the deficits don't matter. So you conclude 80% of the student body believes that deficits don't matter. Should you send your findings to the school newspaper or maybe to CNN? Well, of course not. Why not? Well, because that would be a hasty generalization. Why is it a hasty generalization? It's because you don't have enough information to make the more broad general claim that the whole student body doesn't care about deficits. You've only surveyed 5 people. So you can't actually move from the information you have, those 5 instances, to the much broader, more general claim regarding the whole student body, right? That would be an illegitimate move. It would be a fallacy, a hasty generalization. And that's because of the sample size, right? That's why sample size matters so much. And this happens all the time. So I'm going to read a couple other sort of examples from the textbook here. One says, you should buy a Dell computer because they're great. I bought one last year and it has given me nothing but flawless performance. Well, just because, your particular computer is working really well doesn't mean that all Dells are perfect. That would be a hasty generalization. Another one says, the only male professor I've had this year was a chauvinist pig. Therefore, all male professors at this school must be chauvinist pigs. Well, that's not necessarily true. You can't make that broad generalization based upon one instance like that. I like to think of myself as not a chauvinist pig, but I'm a male professor. So all it takes is having one case, one instance where you have a male professor that's not a chauvinist pig to invalidate that particular argument. Another interesting example here from the text reads, psychology majors are incredibly ignorant about human psychology. Believe me, because I know what I'm talking about. My best friend is a psych major. What an ignoramus. Talking about his best friend, I guess. Another example here reads, the French are snobby and rude. Remember those 2 high and mighty guys with really bad manners? They're French. I rest my case. And finally, the last example from the text reads, the food at Pappy's restaurant is awful. I had a sandwich there once, and the bread was so stale. Right, so those are just really clear examples of hasty generalization where you can't make that broad generalization based upon the small instances that you've observed. That's why sample size matters so much. Now, there's a few other points that I want to call your attention to before we move on. One is this idea of a replication problem or a replication crisis that currently exists within scientific studies. This is occurring both in psychology as well as things like physics and other scientific disciplines or sub disciplines. So I've included a couple of different videos that I want you to watch after these that help illustrate what's going on with the replication crisis. And I want you to think about how this relates to sample size and this notion of hasty generalization, where it might seem like we've got the right number of people, but or the right number of instances that we're considering, but we need to double check and we need to make sure that we really can move from the things that we know to the things that we don't know, that move from the evidence and go beyond the evidence. So here's the basic idea of what's going on with replication crisis and contemporary scientific inquiry. The basic idea is this. There's a kind of demand that people publish. It's this idea of publish or perish. And so what gets funding in order to do different scientific research are things that haven't yet been published. And that's a problem because an important part of scientific studies in the scientific method is being able to reproduce your findings. Different groups, different organizations at different times and different places should be able to replicate the findings if it's good scientific information, right? That aspect of replication is a way to verify or to double check that we have a good sample size and that we are able to make the move from those individual instances that we're observing to the more general, broad claim that we are concluding in our research, right? So when we fail to replicate, that means that we're leaving out an important check on our sample size, as well as a number of other important aspects within the scientific method as well. But that's a key aspect of the scientific method, is to be able to replicate our findings. And it turns out that in many cases, we simply are not actually going through the process of replicating the research. And that's because there's this need, this pressure to publish or perish. And so we have grad students, we have different folks and individuals within the scientific community that are getting funding to research and to look into investigate stuff that has not been published yet. So if all of the money and funding is going to things that we have not yet published on, then that means that the funding is not going towards replication. Who would want to, write a research grant, a grant proposal to perform some experiment that has already been, produced some results, right? That's not the flashy, sexy thing that people are interested in when it comes to going out money for grants and for different research projects. And that's especially problematic given what's going on in our current government, where they're slashing grant funding left and right for really quite political reasons. Right. So I want you to watch these videos on the replication crisis and think about how that affects enumerative induction and the things that we're talking about here in this particular module. Now, the other thing that I want to call to your attention is some more general ways in which we can, double check to make sure that we do have the right sort of sample size, to make sure that our sample size is large enough, right? Because we only have so many resources and so there's only so much that we can do. And so we need some kind of criteria to help us understand when we do have the right sample size. On the one hand, we can certainly use common sense. I think in the case, the example I read from the text, the one dealing with the students who, only interviewed 5 people, our common sense tells us that that's just too small of a sample size. But it might not be as clear in some of the other cases. But I think that if we try to, step back and really consider our intuitions and our common sense, that will be at least an initial way to help consider whether or not we have enough people, enough instances, enough observations that we're making. Another way that we can, kind of double check is by creating a bell curve. By using a bell curve, creating this sort of a graph, that we can see where the averages might fall, and that also can help us consider and determine whether or not we do have the right sample size. Finally, we can consider how homogeneous the target is, right? The more homogeneous the target is and the relevant sorts of traits or the properties in question, then the smaller the sample actually needs to be. Whereas the less homogeneous the sample is, and the respect to whatever property we're considering, the larger it needs to be. So, what do I mean by homogeneous? The basic idea is when we consider the sample size and we're considering the target group, we need to think about how similar are these individuals. If they're very, very similar in all sorts of different respects, then we can have a smaller sample size because it would be more homogeneous. But when the group and all the individuals are much less homogeneous, if they're very different in a lot of different ways, then the sample size needs to be much larger. Right. So these are the different things that we need to consider as different kinds of criteria that we can use when we're considering the sample size, especially as it relates to, certainly as it relates to double checking and making sure that we're not engaging in some fallacious reasoning involving some kind of hasty generalization. All right, so what we're going to do in the next video then is we're going to turn to this idea of representativeness. We're going to consider what exactly that means in more detail. So that's what we'll do in the next video.